Bismillahirrahmanirrahim. Welcome to the first part of fifth lecture of statistics and probability theory. In the previous lecture, we have studied total law of probability. Total law of probability defined that if we have a sample space and we defined mutually exclusive and exhaustive events on the sample space like A1, A2, A3 till AN, and all of them are mutually exclusive, that is non-overlapping. Means if we take intersection of these events, it would be empty set. And there is some other event B defined on the same sample space. So whenever B will occur, it will come in the conjunction of any of the AIs. Means it could come with the conjunction of A1 or A2 or A3 up to so on till AN. So you can find out the probability of B by using the total law of probability, which is equal to probability of B intersection A1 plus probability of B intersection A2 up to so on probability of B intersection AN, which would be equal to summation probability of AI into probability of B given probability of AI, where I is equal to 1 to n. Topic of this lecture is Bayes' theorem. Let us define the Bayes' theorem first. Let A1, A2, AN be a collection of n mutually exclusive and exhaustive events with prior probabilities of probability of AI, like these are mutually exclusive and exhaustive events, and we know the occurrence probability of each event, which is called prior probability, where I is equal to 1 to n. That is, whenever we substitute I is equal to 1, it means probability of A1. And if we substitute I is equal to 2, it would be probability of A2. Then for any other event B for which probability B is greater than 0, probability of B greater than 0 means there should be some probability of occurrence of the event B, as we know that if the probability of any event is 0, it would indicate that it is the impossible event. Then the posterior probability of AI given that B has already occurred is this. As you can see that the word given that is used. If you remember from some previous lecture, we have studied conditional law of probability. Like if we have any two events A and B, where the information of B is already given and we have to find the probability of B, so what will we do? We have to find the probability of A given that B has already occurred. It would be equal to, by applying the conditional probability A intersection B divided by probability of B. This is probability of A given B, that A is occurring given that B has already occurred. If we concentrate here, we have the same situation. We have to find the probability of AI given that the B has already occurred. By conditional probability, this could be written as probability of AI given that B has already occurred is equal to probability of AI intersection B divided by probability of B. This is the situation same as this conditional probability, but as we know that probability of AI intersection B can be opened by applying the multiplicative law, which would be equal to probability of AI into probability of B given that AI has already occurred, divided by probability of B. So, how can you find the probability of B as B is coming with the conjunction of any of the AIs? So, probability of B can be found out by applying the total law of probability, that is probability of B is equal to probability of AI intersection probability of B, where summation is applied, I is equal to 1 to n, which is equal to summation I is equal to 1 to n, where this could be opened as probability of AI into probability of B given AI, where I is equal to 1 up to so on till n. Same is the case here. Probability of B can be found out by this summation probability of AI into probability of B given AI. As we can open the summation, this would be probability of A1 into probability of B given A1 plus probability of A2 into probability of B given A2 up to so on plus probability of AN into probability of B given AN. This is called the Bayes theorem. You can find out you know that B is occurring. You can find out that which of the A is coming in the conjunction. What is the probability that A1 is coming with the conjunction of B? You will substitute I is equal to 1. If you want to find that A2 is coming in the conjunction of B, then you will substitute I is equal to 2. Example. This is the same example as we have discussed in the slides of total law of probability. There are 3 boxes, each containing a different number of light bulbs. The first box has 10 bulbs, of which 4 are dead. The second has 6 bulbs, of which 1 is dead. And the third box has 8 bulbs, of which 3 are dead. If we define the scenario as we have already defined in the lecture of total law of probability, that there are three boxes: box number 1, box number 2, and box number 3. Selection probability for each box is 1 by 3, 1 by 3, 1 by 3. That is, we are applying the definition of probability of an event, number of favorable outcomes divided by total number of outcomes, which is 1 by 3. There are two options, that either the bulb is dead or either the bulb is active. If the bulb is dead, we represent it with D, and if it is active, we represent with D bar. The selection probability of the dead bulb from the box 1 is 4 by 10, because we have total 4 bulbs, dead bulbs, in the box number 1, and total bulbs are 10. So, by applying the definition of the probability of an event, number of favorable outcomes divided by total number of outcomes, the probability of selection of dead bulb from the box 1 is 4 by 10. And the dead bulb is coming from the box 2, the probability is 1 by 6. And the dead bulb is coming from the box 3, probability is 3 by 8. Now what we have to find? If bulb is randomly chosen and is a dead bulb, we have given the information that bulb is randomly chosen and the bulb is the dead bulb. What is the probability that the selected bulb is coming from the box 2? So, you have to find the probability that the bulb is coming from the box 2, but the information already given us that the bulb is the dead bulb. So, we have to find out that the bulb is coming from the box 2, that is, bulb is coming from the box 2. We have to find this probability given that the bulb is the dead bulb, because this information, if the bulb is randomly chosen and is a dead bulb, is already given. So, by applying probability of B2 given D would be equal to probability of B2 intersection D divided by probability of D. So we can apply the Bayes theorem here, which is probability of AI given B is equal to this. Here we have applied the Bayes theorem, which will be equal to probability of B2 into probability D given B2 whole divided by probability of B1 into probability of D given B1 plus probability of B2 into probability of D given B2 plus probability of B3 into probability of D given B3. We can find out from this tree diagram the probabilities of the mentioned events. Probability of B2, that is probability that the box 2 will be selected, is 1 by 3. And probability of D given B2, that is dead bulb is coming from the box 2, is 4 by 10. Probability of B1, this is the selection probability of box number 1, which is 1 by 3, into probability of D given B1, that is selection probability of dead bulb from box 1, is 4 by 10. Probability of B2, which is the selection probability of box 2, which is 1 by 3. And probability of D given B2, which is the selection probability of box number 2, which is the selection probability of dead bulb from the box number 2, is 1 by 6, plus probability of B3, which is the selection probability of box number 3, into probability of D given B3, that is the dead bulb is coming from the box number 3, is 3 by 8, which is we will get this information. On simplifying this, we will get the probability that bulb is coming from box 2 given that the bulb is the dead bulb. Similarly, you can find out the probability of B1 given D, that is bulb is coming from the box 1 given that the bulb is the dead bulb, or also you can find out that bulb is coming from the box 3 given that the bulb is the dead bulb by applying the same Bayes theorem. Similarly, you can also find out that probability of bulb coming from box 1 given that it is the active bulb. You can use B2 also, that is probability of B2 bulb is coming from the box number 2 given that it is the active bulb. Similarly for B3 also. Just concentrate it how would you will find out by using the Bayes theorem.